Today's curiosity is assisted by Hired Hand Brown Ale from Heritage Farms Brewing. They describe it as a medium-bodied brown ale with moderate sweetness, balanced bitterness, and pronounced flavors of biscuits and caramel, with a bit of toffee and chocolate thrown in just for good measure. And they also say that it's made for Manitoba winters, which is exactly what we've got going on right now, though I shall not be discussing politics on this here YouTube channel. So today's curiosity teardown is something that I found in a snowbank when I was out for a walk a week or so ago. It's got a couple of suction cups on the bottom of them, and one of them seems to have had a catastrophic failure. Well, not the suction cup, but its mount. The sticker on the bottom says it runs on 12 volts or 24 up to 24 volts DC. And we got it looks like used to be a 2-wire connector, but there is a 3rd wire in the cable here. But I'm going to guess the red and black wires are positive and ground, or positive and negative. On the top, there's just, scuffs and stuff. Around the sides of it, we have lenses all the way around. Now, before I connect this up to power and see what it does, I have a pretty good idea what it does. Let's place your guesses down below, I suppose. But I don't think it will be any surprise to anybody when those lenses on the sides start blinking. I'm going to guess, I'm fairly confident, that this is one of those lights, flashing beacon lights you suction cup to the roof of your vehicle. I'm further going to guess that this is probably either amber or blue, which is what snowplows would be using around here. 12 volts on the power supply, power on. Yep, looks like amber on this side, blue there. More amber on that end, more blue there. And the same things on the other side. Okay, and it looks like it's blinking a few different patterns. I don't recognize any particular Morse codiness in there. I think it's just flashing away. Anyways, I'm going to turn that off so that I'm not triggering anybody's epilepsy any more than I already did. So that's pretty much what I figured it was. But the reason for today's video is to open it up and see what's going on inside it, what makes it do what it does, see if there's any other adjustments. I'm going to assume that that yellow wire that was in here may be a trigger to change modes or something. And if we can find a manufacturer name on this or something like that inside, maybe we can look it up and see if we can figure out what that yellow wire does. Anyway, there are 6 screws on the bottom of this. So I'll quickly yank those out and come back to you when I've got them out. So is that all it takes to get it apart? Let's make it a bit of prying in here. Ooh, that doesn't look like it wants to. Oh, maybe it's gonna come. I just need a stronger tool than the spudger. I think yeah, there's some gaskets in there and some goop, so I'll just get a little bit more forceful on it, and there we go. Oh, one of the suction cups has fallen off the bottom. Okay. Oh, the suction cup is hiding a bunch of magnets. I guess that makes sense. The suction cup isn't the main thing that was holding this onto the vehicle. It was the magnets, and this was more of a cushion. But okay, so that's on the bottom, and here is what's going on inside it. Looks like the bashed in plastic at that end wasn't too impacting on anything. So here is the central circuit board. Looks like it's got one connector going out to each of the LED modules around the perimeter. And there is the 3 wires coming in. Just going to pull some of this black goop out of here. I'm assuming that's the same goop that they use to weatherproof all the connections coming in. Very rubbery, very silicone-y. But maybe if I can pull some of that out, we can read the labels for these wire connections. So under the black wire, it says ground. Under the red wire, it says VCC. And under the yellow wire, it just says K. And then there's a T over here on a pad that's not being used. That's not especially informative. I may have to start chasing some traces around. Anyway, we have what appears to be a power supply section over here. Diode, inductor, 2 capacitors, and a power device, which is an XL Semiconductor 2576S. To nobody's surprise, that is a buck converter, so it can run up to 40 volts or an input voltage, which is perfectly reasonable since this thing is claiming it'll run between 12 and 24. Output voltage adjustable, so we'll have to look closer at the circuit to see what output voltage it is. I guess we can just measure it. Other than that, up to 3 amps. Fairly beefy little dude. Cool. And there is the sort of an application circuit you might expect to see surrounding it. And I'm willing to bet that that inductor is exactly there, and those 3 capacitors and that diode. Sure, that makes absolutely perfect sense. So let's fire this thing up again and just see what the output voltage it's set for is. The tab is grounded, and pin 2 is the output. So it looks like it's doing about 6 volts. Okay. Which I guess means that each of these modules, each of these LED modules, is probably going to be a 6-volt module too. I was just checking in max min mode on my meter here. It looks like 5.3 volts is the most that we're seeing going to these blinky modules, so I suppose there's a diode drop or something in there. Let's look closer. So there is actually a transistor driving each one of these things, which makes perfect sense. I wonder what it is. A09T. Sure, it's just a little 30-volt N-channel MOSFET. Does it say what kind of current handling it has in here? 5 amps. Lots. Okay, that's way more than this thing's going to need. Other than a handful of resistors, there is only this little chip here. Probably a microcontroller. What are you? FT60E122A. Unsurprisingly, it is in fact a microcontroller, specifically a RISC microcontroller, a little 8-bit one with some EEPROM in it. Okay, it's part of a whole family of them. They're available from between 6-pin and up to 16-pin. The particular one we've got here is a 14-pin. It's got timers, it's got PWM, it's got all kinds of stuff as you would expect. There is all the specs. Pause if you care. Important things for me, because I'm not going to be reprogramming this thing, obviously, is that it runs on 5 volts and it's got GPIO. Sure, that's about all we need to know about it. If you want to know more, there is lots and lots. There's like 81 pages of stuff. I'm not going to go through the whole thing. But there is the pinout of the particular 14-pin one we've got. So the power is in the middle. That's odd. In a lot of cases, on a lot of chips, I find power and ground on the corners. But in this case, it's in the middle. Strange. Anyway, I/O surrounding that all the way around. Sure. Let's see if we can figure out where a few things connect to this. Again, not that it really matters. We're not fully reverse engineering this. We're just trying to understand how the overall circuit works. So yeah, as we saw, the ground is over there. That makes sense. The output of that should be the power over here somewhere. That was pin 2, wasn't it? I think so. Maybe there's a diode in the way. Yeah, there probably is. Okay, so that should be the power and ground across that capacitor there. Yeah, there's the power on that side, and there's the ground on that side in the middle, just as we expected. What else can we learn? Let's look at one of these MOSFETs over here and see if we can find... Doesn't go directly. Okay, goes through that resistor. And then to a GPIO pin. Okay, so a series resistor on the on the gate, which is a 471, so 470 ohms. That's reasonable enough. And yeah, there is one for the gate of each of those MOSFETs. What else can we learn, really? Not too much more. Oh, that yellow wire. Yeah, that yellow wire that we thought was a control. So does that go to there? No, it doesn't. Or wait, does it go to a series resistor? There we go. What are you? 102 1K resistor? 10 and 2 more. Yeah, 1K resistor. Okay. Does that go to a GPIO pin? Yes, it does. It goes to pin 1. Okay. So looking back here, pin 1 is ISP clock or a GPIO. So the ISP data would be there. So it's probably being used as an input, because you can't do ISP programming with only the clock and no data. So I wonder if we can change the modes of this thing by taking that yellow wire either high or low. Maybe we'll experiment with that in a minute, but first I want to see if there is a manufacturer name on the back side of this circuit board, just so I can see if I can find a manual of some sort. There's absolutely no identifying marks on the back side of this thing. Right. On the upside, it is an aluminum PCB, so this power supply is not going to be over temperatured, that's for sure. Not that it would anyway in use. Well, I suppose if this was on something in California, it might get overheated, but in snowplow use in middle of Canada in the middle of winter, yeah, that's not going to happen. So I'm not holding out any hope that ZY-H01 is going to get me any intelligence, but I'm going to go Googleizing and we'll see. I thought that was going to be harder to find, but it turns out it's just a relatively cheap one from Amazon. Okay, that looks exactly like it, doesn't it? Yeah. 12-inch rooftop police beacon, emergency strobe, etc., etc. Sure. Blue amber is the one that we've got in front of us here. And it looks like there is a second switch on the lighter plug there for reprogramming it. It also claims to have 16 flashing patterns and that it is waterproof. And yeah, except for the gaping hole in the bottom of it from when it crash landed, it did appear to be quite waterproof. So, okay, let's see if we can figure out how to activate these 16 flashing patterns. Based on the picture, it would appear that this wire would either have to be pulled either high or low to activate what's going on for the flashing patterns. Presumably just a momentary. So if I was doing this, I would have it pulled either high or low, and then doing the opposite would make it change states. Makes sense, right? So it looks like it's being held high, so I'm going to guess that if we momentarily pull it low, we'll get a different flashing pattern. And remind me from the beginning of the video, were there a couple of chunks of this that weren't working? Looks like this one is completely dead, and half of this one over here is dead. I don't know. I'll have to rewind and take a look at it. Regardless, that's not important right now. I'm going to take my negative input voltage and just apply it once to that. Oh yeah, that's a different pattern. And again, yeah, that's a different pattern. Ooh, it's chasing around the outside now, except for these dead pieces over here. Okay. That's a different pattern. All right. Now it's kind of filling and unfilling. And going the other direction. Okay, chasing around, sure. Slower version of that. Just steady on. Oh, it's PWMing. To my eye, without the camera, it is steady on right now. Okay, that's interesting. That's just a flashy. alternating left-right, kind of European police car mode. Chasing around in circles again, and the other direction. And is that, yeah, that's back to, I think, what it was originally. Okay, shut that off because it's getting annoying. I am going to put an epilepsy warning in the description, and maybe actually in the title, because I don't want anybody being dropped on the floor and incapacitated by this video. But I think we've learned most of what we want to know. Although there is one more thing. I think I want to see if I can pull these modules out, and it might be neat to run them just standalone, wouldn't it? There we go. Okay, that comes out there, and now slice this goop off the lock on the connector. Now then, if I run my power supply down to 5 volts, because I think that's what those really are, we should be able to power these things on, and I'm going to guess, well, I'm pretty confident, that they will just go on steady state. Think, yep, there it's blue. That's only drawing 2 milliamps. Let's turn it up some. There, now it is 6 volts and it is drawing 90 to 100 milliamps. Okay. Let's pull it down a little bit. There's about 40 milliamps at 5¼ volts. That's kind of a neat little module. Oh, it's got screws on it. Well, that means this video is not over yet. Okay. Let's see what happens inside these little guys. I'm going to guess it's just a bunch of LEDs in parallel, but not at 5 volts. It's maybe going to have a resistor in there. I don't know. Place your bets. Although I'm probably going to have to... Oh no, getting through that weatherproofing's not as hard as I thought. Ah! They looked like they were like 5mm shaped LEDs or typical LEDs, but they're not. They're surface mount. I'm not sure whether you can see the traces or not, but looks like they are set up in 4 series pairs with a series resistor. So from the LED positive voltage coming in, you go to one side of one of the resistors, and then from the other side of that resistor, it goes to this LED goes to this LED, and then that side goes to the LED minus, and it just repeats 4 times, which is why these things were happier a little bit over 5 volts than a little bit under, and we could easily run them on 6 volts. What are the resistors? 2.2 ohm resistors. Okay, not too much current limiting, but enough for what we're doing. Should I pull out that one that wasn't working and just see if I can figure it out? Yeah, maybe. And again, the only thing you really have to do to pop these things out is to break through the silicone weatherproofing, kind of like that. And I think that was the one that was misbehaving. I suppose I could have checked it before yanking it out of there, but whatever. Power on. Yeah, not drawing any current at all. Okay. Ah, these are amber type. Right, I should have expected that. So let's see what we've got. First, do we have voltage coming in? Yes, we do. Okay. Is that voltage still there? Yes. Is it still there? Yes. Is it still there? Yes. Is it still there? No. The minus side, do we have a connection there? Yes. Are all those LEDs burned out? Really? Let's put the meter into diode check mode. Looks like that one is not working, but this one is. That one's not working, but this one is. That one's not working, but this one is. That one's working, and that one's not. Well, that's wild. Why would one of each pair have died? That is odd, but regardless, it wasn't the failure mode that I first thought. I was expecting these would have died because of, you know, the deceleration trauma of this thing falling off the vehicle that it was on. But regardless, I could replace those if I had any. I don't know if I do or not. I don't have a lot of surface mount LEDs, but that's another thing for another time. We've learned what we wanted to know, and we do have some modules that do work that we could use either just as bare modules, or we could put them back in their enclosures and use them with the lenses on them, I suppose. Interesting. I don't have a use for this thing, although that is an interesting regulator, and it can do, what did it say, a whole bunch of amps. Neat. The magnets are probably the biggest salvage off this thing of anything, actually. Although, like I said, these could be fun to keep around, and you never know when you're going to need some lights you can use in an outdoor application, or just really bright. Well, that was fun. Learned a little bit. That's a fairly solid little circuit board, actually, although it did allow those LEDs to be overdriven, which is kind of not great. But for, what was it, $65 or something on Amazon, I guess whoever snowplow this thing fell off can afford to replace it. Well, thanks for watching. I do appreciate that. Questions and comments down below as usual. I'll talk to you later.